We're going to prove some trig identities here. So the first, we're going to look at number 2 and 4 in this video, and we're going to practice doing these trig identities with adding or subtracting. So looking at number 2. It's kind of, well, we're going to do this by addition because I see an addition expression over here. So if you add these two trig expressions together, somehow you're going to get this. Now, when you're adding trig expressions together, usually you want fractions because that you'll be able to get a common denominator and you'll get some kind of change to happen that would force this to look like this. And sometimes it's not so easy to tell what's going to happen. You just have to do it. So the first thing I always like to do, I always like to deal with sines and cosines whenever possible because those are usually easier and everything can be written as a sine and cosine. So I'm just going to look at this side and change it to sine and cosine first. So everything can be, as I said, changed to sine and cosine. Cosecant is 1 over sine. And cotangent is cosine over sine. So just changing this to sines and cosines looks really good because now when you have fractions, you're always looking for a common denominator, and you already have one. They're both sine of x. So whenever you have a common denominator, you can just write it as a single sum or difference over that common denominator. So I have 1 plus cosine over the common denominator, and I'm done because I just made this side look exactly like this side. So that was a lot easier than it looked like it could have been. And that's what happens a lot on these problems. And when all else fails, always try to changing into sine and cosines. So let's go to number 4 because that looks a little bit more complicated. So the left-hand side is a whole bunch of trig functions and their difference is 1. So here we go with that one. I'm going to work on this side. Obviously, I'm not going to get 1 to look like this. So I'm going to make the left-hand side look like 1. So first of all, I'm going to change the sines and cosines. Just because that's what I like to do, especially if I have no other idea of what I should be doing. So one way I like to do that is I like to bring everything up. Now, this isn't completely necessary here. There may be some steps that are not needed or too much, but I'm going to try to be consistent. So if I have this secant over cosine, first thing I'm going to do is bring the cosine up. And that would get it out of a cosine. It would make it its reciprocal, which is secant. But I'm going to fix that later anyhow. And then here, I'm going to bring the cotangent up and make it its reciprocal. Now from here, you could, if you're really good with the trig identities, you can realize that this is secant squared minus tangent squared. And then you can get to 1 pretty easily from there. But I'm going to go with my first guess, and I'm just going to subtract these by getting a common denominator. So what I like to do here is change in both the sines and cosines. So secant is 1 over cosine. Tangent is sine over cosine. So now I'm all sines and cosines. So multiply these together. So 1 minus 1 over cosine times 1 over cosine is 1 over cosine squared. Sine times sine is sine squared. And cosine times cosine is cosine squared. So I do have a common denominator here, so I can write this as 1 minus sine squared all over cosine squared. So now here's, again, I'm going to have to use a Pythagorean identity, but this may be one that I'm more familiar with. The Pythagorean identity that we should definitely know is sine squared plus cosine squared is always equal to 1. So if you look at and the key thing is here, look for the squares. That's where a Pythagorean identity most likely is going to come into play. And if I see the top, I'm going to do it over here. The top of my fraction is 1 minus sine squared. So according to this Pythagorean identity, 1 minus sine squared, if I move this over, that would be 1 minus sine squared, is equal to cosine squared. So that 1 minus sine squared up top is cosine squared. And I do have cosine squared over cosine squared, that means. And cosine squared divided by cosine squared is 1, of course. And that's what I was trying to show. So I've just proved that identity. So again, that's a good way to do it if you're just really good with sines and cosines. You could have shortened this problem pretty much by noticing that this is sine squared minus tangent squared and using that identity. But I find most people forget those identities and are more familiar with sines and cosines. So that's the other way to go. So hopefully that helps a little bit. The best thing you can do with these is practice. So do it.